Dear students, as you have been engaged in a different class, that is mathematics class, I am now preparing a video for the class which I was supposed to take today. Basically, we have discussed probabilistic randomized algorithms, and we discussed in the last class the Monte Carlo algorithms. The Monte Carlo algorithms is basically the polynomial equality example I have taken, and you need to implement that in the lab. There is another algorithm which you need to discuss, that is the Miller-Rabin algorithm, which we can do after understanding what is Miller-Rabin in the numerical algorithms class. Now I will go to the Las Vegas algorithms. A Las Vegas algorithm has a characteristic that it never returns an incorrect answer. However, it is subject to two types of disasters. It could run arbitrarily long without producing an answer, or it could make a random decision from which there is no recovery. But these two errors are of very small probability, and if you run this algorithm multiple number of times, you will definitely get a higher probability of success in getting a correct answer from this kinds of algorithms. A Monte Carlo algorithm for which there is an efficient way to test whether the returned result is correct can be turned into a Las Vegas algorithm by simply repeating the algorithm in case an incorrect answer is returned. So you should understand this, that the Las Vegas algorithm is such an algorithm which goes on returning answer. But when you run an algorithm which returns a wrong answer, and we know that it is a wrong answer, we can go on returning multiple times, running it multiple times to get the correct answer. One of a typical example of say a Las Vegas algorithm is a random search. A random search is a search wherein you just go to a random location in the array where you want to search for an element and check whether the element is present. And it will definitely always return a correct answer, that is either that element is present or not present, but it will only check one location. So if you repeatedly go on checking multiple number of times, you will be getting a correct answer at least once if the element is present. If the element is not present, you will get a wrong, not present answer. So one of this example is displayed on the screen, and that is a random search. The input to this is an array of elements, and a search element is occurring in this at least k number of times. The output returns an index of an occurrence of x in L. So what we are doing here is we are going to multiple, say in a iteration, we are going to check for existence of the given element, the element we are searching for, that is x, by choosing a random location within the array, and if that is equal to L of choice, then we say found equal to true. Otherwise, we go on selecting another random number between that location and go on doing this. So once only this goes on repeating, it will never return a wrong answer. It will always return a correct answer until there is found, assuming that it is present. So this particular thing is it is present, you are going to get the location where it is present. For that, this random search is definitely going to give the correct answer always. Hence it is a Las Vegas algorithm. And it is noticed that it is going to use random numbers. Since it's a randomized probabilistic algorithm, it may give a best case probability of whether it is in the last location, mid location. There is a probability of getting the location in the first iteration itself, or it may take multiple iterations. And it can be shown that the worst case time expected is n divided by k, where k is the number of elements, number of times that particular element x is present in the array. And this can be proven also. You can refer to the textbook for referring or to find this particular derivation of the worst case time complexity. The best case is equal to 1. The next topic is about the probabilistic random algorithms, or say probabilistic numerical algorithms. Now almost all the numerical algorithms have some deterministic procedures to get the solutions. For example, if you want to understand what is the integration of a given function between two different values a and b, there are different methods such as the Riemann left point Riemann sum, the right hand point Riemann sum, trapezoidal rule, Simpson's rule. Many such things exist. Now what we can also get this solution, an approximate solution to this, using the randomized or probabilistic numerical algorithms. The probabilistic numerical algorithms give an approximate answer, but as the number of points increases, the approximation will near to the actual value. One of the method which is shown as which we discussed is known as throwing of darts. Throwing of darts, what it does is, if there is a function f of x which is shown here as a curve y is equal to f of x, and we want to find its integration between a and b, what we do is we enclose that particular curve into a rectangle wherein a, b are the borders on the x-axis and m is the border on y-axis. So it is a rectangle which says a0 and b0 as one of the points, and am and bm as another set of points of the rectangle. Now what we do is, so we are going to throw the darts, and if the dart is less than f of x, then we can count that 1 here, and as the number of darts are going to be thrown, some may be outside of f of x, some may be less than f of x, some may be greater than f of x. So if you find those less than f of x divided by the total number of darts and multiply that by the area of the rectangle, we are going to get the approximation to the area of the curve, area under the curve f of x. So this is going to be depicted or found by this algorithm. Here you can see here throw darts. F is the function, a and b are the values, m is the rectangular value which is going to be provided, n is the number of points you are going to use as a sample. The output is an approximation to integration of f of x dx. So we say hit target is assigned a value 0. For dart 1 to n, you find a random number between a and b, and for y you find a random number between 0 and m, and if y is less than of f of x, that is it lies within the area of that curve, we increment hit target by 1. Otherwise we again continue until n points are found. Now what we do is, the hit target divided by n is the ratio of the number of points which are going to be lying within the curve, and n is the total number of points. Now the area of corresponding total number of points is m into b minus a, that is the rectangular area. If we multiply that, that is going to give us an approximation of the integral under the curve f of x. So this is about one method. Now another method of finding the integral is referred to as approximate mean value integral. Basically what we are trying to do here is, we are going to find the average of the different ordinates. We are going to compute f of x and we take a mean, and once we take a mean, then we are going to multiply that by the area that is between a and b, whatever is the area, and if you multiply that, it is going to give us an approximation. It is very simple. If you see this algorithm, input is a function f, and a and b are the endpoints. A positive integer equal to the number of points sampled, as we did in the previous method. Then we have the sum is assigned to 0, and then we go on finding the random values between a and b. Then you compute f of x, sum that, then we multiply this by b minus a and divide by n to give an approximation to the integral or the area under this particular curve. So both of these methods are going to give the area under the curve as a probabilistic functions. The probabilistic functions are going to be adapted here. So both these methods which we have discussed are probabilistic numerical algorithms for finding the integral, a definite integral between, for a given function, between the points a and b. Now this gives us an idea as to what are numerical probabilistic algorithms, and we have also discussed the Las Vegas algorithms. There are other points which you need to understand, and that is the estimating the size of the set. So I will give it as an assignment, and maybe I will host that, or the assignment I will post in the Google Classroom also. And probably I will also share this video in the Google Classroom. And thank you for listening to this. If you have any questions, you can contact me on phone or through WhatsApp. Thank you.